You're welcome, learners, to a part 2 of approximation. Another that we have decimal places and significant figures. Like I promised when we are doing the part 1 that we'll be taking part 2 to take care of the concerns of our learners who are in higher classes, like those who are preparing for SSC, JAMB, and other higher exams. We'll be taking our examples from Hidden Fact in New SSC Mathematics. Example 1. Which of these numbers is correct to three significant figures? A. 0.003. B. 0.0034. C. 0.012. D. 3.04. Solution. We are analyzing each of the options to see how they are presented. First, option A, 0.003 is correct to two decimal places and correct to one significant figure, but not three significant figures. The reason is, if you look at is 0.003. Why we say it's correct to three decimal places there is that your decimal point can only move 3.123 before it ended, and you have, that is why we are saying it's correct to three decimal places. But as for significant figure, is the first non-zero digit we are dealing with. And here, the first non-zero digit here is 3. So, there is no other digit after that 3, which is to say, this expression was rounded up correct to one significant figure. Let's look at option B and see how it was presented. 0.0034 is correct to 4 decimal places and correct to 2 significant figures. Why do we say that? If you are to move your decimal point towards the end after 4, you will see that it will move 4 places. 1, 2, 3, 4 before you get to where 4 is. That's why we said it's correct to 4 decimal places. And when I said it's correct to 2 significant figures, if you look at the 0.0034, the only non-zero digit there are 2. And after 3, 4, no further digit was given. So you can conclusively say it is 2 significant figures that was considered in approximating this. Let's look at option C. 0.012 is correct to 3 decimal places and correct to 2 significant figures. Yes, it's the same explanation. If we look at it, if you are to move your decimal point from where it is now, in that 0.012, it will move 1, 2, 3. 3 points. That is why we said before you land at the final point after 2. So that is why I said it's correct to 3 decimal places. But as for significant figure, we don't look at decimal places, we look at the non-zero digits, non-zero numbers there. And it's 1, 2 we have there. So only 2 numbers. That is why we said it's correct to 2 significant figures. After 1, 2, there is no other number. And that's why we said it's correct to 2 significant figures. Let's look at option D. 3.04 is correct to 3 significant figures. And if we may care to add, it's also correct to 2 places of decimal. So if you check very well, our question target is which of this number is correct to 3 significant figures. So 3.04, the non-zero digit we started with is 3. Then we have 0 after decimal, then we have 4. So we conveniently, once you have noticed your first non-zero digit, you start counting. Here, the first non-zero digit there is 3. So you start counting from there. 1, 2, 3. So there are 3 numbers. And so that's why we conveniently said it's correct to 3 significant figures. And if it's decimal place, we are only concerned about numbers that appear after the decimal point. And that is why we said it's correct to 2 decimal places. Because after decimal place, you have 0, then you have 2. That's why we said it's correct to 2 decimal places. Now, let's take another example. Example 2. Approximate 0.00337780 to 3 significant figures. The options are given there. A, 338, B, 0.338, C, 0.00338, D, 0.003. Solution. In significant figures, our concern is the first figure, not 0 or decimal point. So we take 337 for 3 significant figures and approximate there. So 0.0033780 we approximately equals to 0.00338 to 3 significant figure. We rounded up by adding 1 to our 7. That's why you have 8 there. You know, you have 337. That's where we're supposed to stop. But since 8 is a number after the 7 and it's above 5, 8 is above 5. So we added 1 to that 7, making it 8. Let's take another example. Express 302.10495 correct to 5 significant figures. A. 302.10. B. 302.11. C. 302.15. D. 302.1049. Solution. In significant figures, our concern is the first non-zero figure. So, for 5 significant figures, we take 302.10. Then we approximate and we approximate. Our value will become 302.10495 will be approximately equals to 302.10. If you observe very well, we rounded down here. Reason, after the last 0 in 302.10495 is 4, not the last 0, which we took at 302.10. So if 4 is given, which is not up to 5 and above, then we rounded down. Let's take another example. Express the product of 0.007 and 0.057 to 2 significant figures. Options. A. 0.00040. B. 0.00039. C. 0.0040. D. 0.0039. E. 0.040. Solution. If you look at the question carefully, say we should express the product. So first of all is the product we are looking for. We will do our multiplication. That will be 0.007 times 0.057, which is equals to 0.00399. It is this value, the given answer, that we are now approximating to 2 significant figures. And you recall very well that in significant figures, we are dealing with the non-zero digit. And here, the 2 non-zero digit is 39. Now, if we have 39, after 39 is another 9. So we are rounding down by adding 1 from that 9 to 39. And once you add 9 to 39, you will get 40. So that's why we now have it approximately equals to 0.0040 to 2 significant figure. Let's take another example. Evaluate 0.13 raised to power 3 correct to 3 significant figures. Option A, 0.00219. B, 0.00220. C, 0.00300. D, 0.00390. Solution. Here we are given first operation to perform on 0.13, that we should raise it to power 3, and that will give us equals to 0.002197. To 3 significant figure, we are approximating it to 3 significant figure. So we carefully put the first significant figure, let us indicate them, will be under 2. The second significant figure will be under 1. The third significant figure will be under 9. And we just, for clarity purpose, we just put 0 under the 7. Now you will observe that next to the last digit 9 is 7. So we rounded up by adding 1 to it. Therefore, 0.002197 is approximately equals to 0.0022 to 3 significant figure. Another example. Evaluate 6.42 plus 2.13 all over 4.1 minus 2.85. Correct to 2 significant figures. The options are A, 6.9, B, 6.8, C, 5.9, D, 5.8, E, 5.4. Solution. Solving the numerator and denominator differently. Since we know that the numerator is addition, the denominator is subtraction, we just do our simple arithmetic there. Hence, we have a result 6.42 plus 2.13 all over 4.1 minus 2.85 will be equals to 8.55 all over 1.25. That will give us a result of 6.84. It is this result that we are approximating to 2 significant figures. You know, when we are dealing with significant figures, is the first non-zero digit. So we write first under the 6, second under the 8, and since it's 2 significant figures, we can just put 0 under 4. Next to the last digit, 8, is 4. So we rounded down by adding nothing to it. Thus, 6.84 is approximately equals to 6.8 to 2 significant figures. Let's take another example. Express the difference between one whole number 7 over 25 and 17 over 300 to 3 significant figures. The options: A, 1.22, B, 1.23, C, 0.12, D, 0.13. Solution. We are to solve the simple arithmetic there of one whole number 7 over 25 minus 17 over 300, which is equals to, first of all, we change our mixed fraction there into a fractional value. That will give us 32 over 25 minus 17 over 300. Changing from fraction to decimals, because our result they are given in decimal numbers. So 32 over 25 will give us 1.28 minus 17 over 300 will give us 0.05667. Now the value of this subtraction will be equals to 1.22333. And remember, we are dealing with 3 significant figures. So let's just label them. Number 1 will be the first significant figure there. After the decimal point, 2 there will be the second significant figure. And then the other 2 will be the third significant figure. And remember, we are dealing with 3 significant figures. So we just, for ease of working, we put 0 under the remaining 3. 0, 0. Next to the last digit 2 is 3. So we rounded down by adding nothing to it. Thus, 1.22333 is approximately equals to 1.22 to 3 significant figure. Let's take another example. Express the sum of 0.0714 and 0.0163 in 2 significant figures. Options: A, 0.080, B, 0.086, C, 0.087, D, 0.088, E, 0.090. First, we will perform the operation of the summation. So we present our solution as thus: 0.0714 plus 0.0163. All the numbers are the same length of numbers, so it's very easy to perform this operation. When we do our addition, we have our addition. The result will be 0.0877. In significant figures, our concern is the first figure, not 0 or decimal point. So we take 8, 7 for 2 significant figures and approximate. Thus, 0.0877 will be approximately equals to 0.088 to two significant figures. The reason why we have this is rounded up by adding 1 to 7 in 87, since the number after 87 is 7. Let's take another example. Express 42.467 to two decimal places. Options: 424.67, that's option A. B, 42.50. C, 42.47. Option D, 42.46. When dealing with decimal places, our starting point is decimal point. Immediately after decimal point, we start counting. So we take 0.46 for approximation to two decimal places. Thus, 42.467 approximately equals to 42.47. Since the number after 0.46 is 7, we rounded up by adding 1 to the 6. Hence, we have that result of 42.47. Another example. Simplify 0.0589 plus 7.382 minus 0.7953. Correct to two decimal places. Our options are given: A, 6.60, B, 6.64, C, 6.65, D, 8.20, E, 8.24. If we look at the problem very carefully, you will see the presentation of the problem is done in such a way to make the average student get confused. The first two numbers there are addition, but the last one is subtracted. And all the numbers presented, they are not of equal state. So careful arrangement is needed. Let's write out the first number, 0.0589. Then we take it after the decimal, 7.382 with a asterisk to know that no number is filling that gap. This is what we have to add. And when we add, we get the value 7.4409. Take note, it must be noted that our addition starts from the right, proceeding to the left. So first of all, you write 9, then you add 8 plus 2, 10, then you carry 1. 1 to 5 plus 8, which is 13 plus 1, gives you 14. Then you carry 1, again, add to the 3, and that gives you 4, bring 7 down. Then we cannot conveniently do our subtraction. Bring down the number for subtraction, which is 0.7953. Now, when we do that subtraction, our result will be 6.6459. Note the subtraction. Let us take note of how the subtraction was performed. You start from the right and proceeding to the left from the first set of number, not from the decimal point. Is the last set of number. So 9 minus 3 will give you 6. Then 0 minus 5, you cannot. So you borrow 1 from 4 and put there. That will give you 10. So 10 minus 5, you get 5. Now, that position, you are now left with 3. And 3 minus 9 cannot. So you borrow 1 from 4 again and add there. That will become 13. 13 minus 9, you get 4. Now, you are left with 3. 3 minus 7 cannot. So you borrow 1 from 7 and put there. And that will be 13. 13 minus 7 will give you 6. So you are left with 6. They already have borrowed 1 from the 7. So that 6 is what we dropped there. I hope that arithmetic operation is understood. Now let's get back to our concern here. In decimal places approximation, our concern is the decimal point. Immediately after decimal point, we start counting. So we take 0.64 for approximation to two decimal places. That will now give us our result. 6.6456 approximately equals to 6.65 to two decimal places. Since the number after 0.64 is 5, we rounded up by adding 1 to 4 in 0.64 to become 0.65. Another example. Sum up the following numbers: 0.032, 4.154, 6.0, and 0.3065 to two decimal places. Option A, 10.00. Option B, 10.40. Option C, 10.49. Option D, 10.50. Option E, 11.00. Solution. Here we are going to carefully arrange the number. Everything about here is summation, addition. But the problem was carefully presented in such a way the examiner wants to know whether you can arrange numbers properly. Now first we write the 0.032. We'll put a star. You see the reason why we did that. Then the next number is 4.154. Put a star. We're adding. And the next number is 6.0. Put star, star, star. And the last number there is 0.3065. Our solution will give us 10.4925. Let me explain how we got our solution of the simple arithmetic operation here. Why we introduce that star is that we observe in all the numbers that we are given, the digits that we are given, the biggest one there in terms of space occupations, not necessarily the biggest number, is 0.3065. So hence when we are adding, we introduce star to make up for the gap that were not filled by the first three set of numbers. And in adding, we add from the right going to the left. And if you look at it, that's why the first number there, 5, was written down there. Now, when you add, the next to it is 2 plus 4, that is 6. 6 plus 6 is 12. Put 2 down, carry 1. 3 plus 5 is 8, plus the one we carried, that gives you 9. Now, next we add 1 plus 3, that's 4. Then after the decimal point, you look at it, 4 plus 6, 10. We write the 10 down because no further operation, so we write the whole number there. Now let's get back to the two decimal places of our concern here. In decimal place, we start counting after decimal point, whether it is 0 or not. So we take 10.49 for two decimal places and approximate. That is to say 10.4925 is approximately equals to 10.49 to two decimal places. Reason, when we rounded up our 10.49, after that we had 2, so there is nothing to add, hence we left it like that. We are rounding up and it's 2 after the number 9. We can't add anything, we just round down. Let's take another example. Evaluate 1/2 plus 3/20 plus 5/200 plus 7/2000. Correct to 3 decimal places. Options: A 0.685, B 0.680, C 0.679, D 0.678, E 0.670. Solution: since we are working in decimal places, we change the fractions to decimals, having our 3 decimal points in mind. Hence, our 1/2 plus 3/20 plus 5/200 plus 7/2000 will be equals to 0.5, 0.15, 0.025 plus 0.0035. Before I go to the result of the value we're adding, when we say that you have your 3 decimal place in mind, the last value here, 0.0035, if we had written it as 0.003 or 0.004, you are already messing up the work, because 3 decimal place there, you would have stopped having the actual value that is needed. So if we are talking about 3 decimal places, you should give room to 4 decimal places for approximation. Hence, you see our value was written in that way. We didn't throw away the 5 after the 3 because it's 3 decimal places. It's your final answer that should be approximated to 3 decimal places. Now, let us go back to where we were. The value of our summation is equals to 0.6785. Now, let us highlight. To 3 decimal place, we put after our decimal first, the first place of decimal there is 6, second place is under 7, the third place is under 8. So we can conveniently just put 0 under the 5. Next to the third digit 8 is 5. So we round up by adding 1 to it. Thus 0.6785 is approximately equals to 0.6785. 679 to 3 decimal places. Another example. What is the place value of 9 in the number 3.0492? A. 9 over 10,000. B. 9 over 1,000. C. 9 over 100. D. 9 over 10. The decimal place value system of number is, let us arrange this number and begin to get them out, is 3.0492. If we start highlighting, we look at, after the decimal place, we have first. The first decimal point there on top of 0, first. Then second is on top of 4. Third is on top of 9. And fourth is on top of 2. Those are the positions. Now, we know that under the 0 in our earlier explanation, after you have a decimal point, the first number there is in tenth. The second number there is in hundredth. And the third number there is in thousandth. Thus, the position of 9 is thousandth. That is 9 over 1,000. Another example. What is the value of 3 in the number 42.7531? Option A, 3 over 10,000. Option B, 3 over 1,000. Option C, 3 over 100. Option D, 3 over 10. Let's also take it like the last example we treated now. The decimal place value system of number is 42.7532. Now, when you look at after the decimal point, then you know the first position for decimal there is top of 7, and the second position is top of 5. Third position there on top of 3, and the fourth position is on top of 2. Those are the positions. Now, we have learned earlier on that after the decimal point, the first number there is actually tenth. It's in tenth. Second number there is in hundredth. Third number there is thousandth. Thus, the position of 3 in our given number is thousands. That is 3 over 1,000. We have come to the last example we are treating under this session. We'll be giving some exercises for you to try your hand on. Exercises from 1.17 up to 1.23 from the hidden fact in new SSC mathematics, page 8. Once you try your hands on them, the answers are given at the back of the book, which you can check either in the soft copy or the hard copy. Thank you.